Cis-trans geometrical isomerism. Cis-trans geometrical isomerism. Cis-trans geometrical isomerism. First of all, let us see what is cis isomer. Cis isomer. In organic chemistry, cis means two similar atoms present same side to the double bond. That is called as cis. Yeah, once look at this. In organic, this is cis. Am I correct? Some P. Two similar atoms are same side. Cis isomer. Trans means opposite side. Right? Trans means two similar atoms are in opposite. In complex compounds, this is defined like this. Once look at this. I am taking Ma2Bc type ligand. Ma2Bc type means nickel Cl2 bromine iodine. Ma2Bc bromine iodine. I am drawing this complex into different forms. చూడండి టెన్నిస్ అయిపోయిందా ఆన్లైన్లో కూడా మీరు రావట్లేదు కమ్ ఫాస్ట్ బీ ఆన్ టైం రైట్ ఆన్లైన్ స్టూడెంట్స్ two similar atoms are arranged by an angle 90 degree. Between two similar atoms, what is the angle? 90 degree. B and C. This is called a cis isomer. In complex compounds, what is a cis isomer? The compound in which two similar atoms are arranged by 90 degree. A. Here what is A? Chlorine atoms. Two chlorines are arranged by 90 degrees. Look at this. A, B and C. What is the angle between these two? 90 degrees. 180 degree. 180 degree. Say the thing. Well, correct చేస్తుంది. So very easy to define cis-gender trans isomer, right? The complex in which two similar groups are arranged by 180 degree. Correct or not? Angle is 180. Right. Very simple definition for cis-gender trans. Two similar groups are arranged by 90 degree. The complex in which two similar groups are arranged by 90 degree. The complex in which two similar groups are arranged by 180 degree. That is called as trans. 90, 180. Enough. But in organic chemistry, what is this? Ordered isomerism is about
Same side.
two similar groups are present same side to the double bond. Is this? Two similar groups present opposite side to the double bond trans. Which complexes do not show Geometrical isomerism and coordination number 4.
Tetrahedron.
Which complexes do not show Maria?
Ma4 plus
Tetrahedral. Tetrahedral complexes do not show
Ma3D.
geometrical type. Ma4 and Ma3 B type.
So 90 degrees is 180 degrees now.
Right. Geometrical isomerism with coordination number 4. Let us revise once. With monodentate ligands,
Ma4, Ma3.
monodentate and bidentate. With monodentate ligands, which type of complexes do not show?
Ma4,
M4 and
Ma3D.
Ma3B type do not exhibit. These two do not show. Do not show GA. Systems geometrical isomerism. Ma4 and Ma3B. Means if you see this type of ligand, Ma4 type, it won't show geometrical systems geometrical isomerism. If you see this type of ligand also, it won't show geometrical. We have to remember these formats. I given already this yesterday. Okay, you can watch that video. Just I'll give one idea for today's class. I explained briefly in the last class. Next, Ma2B2 will exhibit systems. Ma2B2 means nickel Cl2Br. Nickel Cl2Br.
Ma2BC.
Ma2BC category. Next,
MABC.
MABCD type. These category will show isomerism, systems geometrical isomerism. Shows GA. So, if you remember these formats, then you can identify easily. It shows GA, it do not shows GA. Okay? Right. With the bidentate ligands. Tell me with the bidentate ligands.
MAA2, MAB2, MABC.
Yes. Which do not shows?
N.
MAA taken twice do not shows geometrical isomerism. MAB type
AB2
shows ZA. And here I given another category also. MAA B2 and MAA BC also do not shows. What is AA here? It is a bidentate ligand. Bidentate ligand. Once look at this. Nickel En taken twice. Will it show ZA?
Yes.
No.
Oh, yeah, sorry.
MAA.
Same one.
In ethylene diamond, what are donor atoms?
Nitrogen.
What are donor atoms?
Nitrogen.
What are donor atoms?
So which donates an electron?
No. In ethylene diamond, what are donor atoms? Oxygen or nitrogen or nitrogen?
Nitrogen.
Only nitrogen.
Nitrogen.
Two nitrogen atoms are there. That's why AA I wrote. Symmetrical bidentate ligand. AA represent in that bidentate ligand two donor atoms are same. MAB. AB represent it is a bidentate ligand in that two donor atoms are different. Once look at this. This is oxygen, this is nitrogen. This comes under which category? AB type category. AB type. Two different donor atoms. Okay, let us see examples. Yesterday I given this short. Okay. For optical, have I given for optical? Optical not started, right? Only with coordination number 4 and 6 also. Only introduction, right? Let us start examples. All of you see these examples. MA2B2 will show. MA2BC. MABCD. Right. Examples. MA4 type. You tell me in that category MA4 comes under do not show category. So do not show. Roman number 1 do not show. MA4 do not show. Examples for nickel Cl4 plus 2. Okay. Roman number 2. MA3B category. MA3B category. Which is present under do not show category. Do not show category. Roman number 2. Nickel Cl3Br. So when you see nickel Cl3Br, will it show? No. Because this comes under which category? MA3B category. Very easy. MA3B and MA4 category do not show. Next Roman number 3. MA2B2. MA2B2 category. MA2B2 will show cis-trans geometrical isomerism. Nickel Cl2Br. Will it show GM? Right here also do not show. Do not show. MA2B2. Nickel Cl2Br means this is present under shows category. Okay. Now let us write two forms for this. Online students are it following? Obed, Ayesha, Bhakti. Adiba. Alva type. This is our Bhakti. Nickel. See. First write cis. Br. Cl. What is the angle between two similar atoms? 90 degree. Angle is 90. So this is cis form and trans form. Charge is common, -2 here and -2. Cis and trans. You no need to draw the structures, right? No need to draw the structure, just we are writing for the practice. It is in the form of MA2B2, so it will show geometrical isomerism. How MABCD will show GI? How?
Under optical tetrahedral.
No, on what basis we can say systems? Once look at this. MA2BC is similar to this only, MA2B2 type. Also, I am going directly to MABCD type. MABCD plus or minus 1. This is Roman number 4, fourth category. Examples: nickel, chlorine, bromine, amine, and iron. First, check. This is comes under which category? This comes under which category? ABCD
Shows.
Chlorine A, bromine B, energetic total C, pyridine D. Okay. MABCD type. It shows. Aisha, will it shows or not? It shows because MABCD undoubtedly selection. MABCD category. How can we see whether it is cis or trans? See, in amine, what is donor atom? Nitrogen is the donor atom. PY stands for you read already ligands list. What is PY? PY stands for pyridine. Pyridine. What is donor atom in pyridine? Nitrogen is the donor atom. Cl and the Br. See, we can see some hint or some small concept will be there to decide cis and trans. By taking help of halogen concept or by taking help of similar donor atoms, we can divide into cis and trans. Actually, ABCD means we will get some confusion. How can we classify into cis and trans? But some hint will be there for us. Some concept is there. Based on that concept, it will classify. Nitrogen donor, here also nitrogen donor. Donor atoms are similar or not? Two similar donors are same side or opposite side? Opposite side. 180 degrees. So this is trans. Or halogen. Halogen is same family or not? 7th A group. Two halogens are same side or opposite side? Opposite side. Trans. With respect to halogens we can say, or with respect to donor atoms we can say. Here online students, MABCD type category, with respect to halogens, two halogens. Here we can take halogen belongs to same family. Okay. Here one atom is there, here one atom is there. Bromine atom, fluorine atom belongs to same family. Same family elements are present in opposite, so you can consider it as trans. What about cis then? Halogens are arranged by 90 degree. With respect to halogens or with respect to donor atoms. Two similar donors. Nitrogen donor, here also nitrogen donor, arranged by 90 degree. So trans is one. Trans is one. So this is trans. Online students, are you following all of you? Yes, tell me, Adima. Yes, optical also. That is only the condition. MABCD, because plane of symmetry should not present. In MABCD, plane of symmetry is option. That's right. MABCD will show optical. You are writing exam tomorrow, Adima?
So tomorrow is Saturday.
Adima, are you writing exam tomorrow? Sister. Right. Next category. MABCD is about next bidentate category. Bidentate. Problem number 5. Sveta. What about this? MA taken twice category. Start. See the table. Do not show. Nickel oxalato taken twice. What are donor atoms in oxalato? Oxygen, nitrogen, right? Oxygen and nitrogen. Oxygen and oxygen. Do not show. What is the reason why they do not show? See, I am writing oxalato ligand. What are the donor atoms in oxalato? Oxygen, and the remaining just I am considering as a carbonyl. This is one oxalato. This part is one oxalato. This part is one oxalato. Now you tell me, with respect to which two atoms we can say 90 degree, and with respect to which two atoms we can say 180 degree. Is it possible? That is the reason. Clear? How can we say cis and trans here? Is it possible? Here oxygen on 90, here 180. How it is possible? Same time 90, 190. Here oxygen is 90. Here oxygen is 180. How it is possible? That's right. So when you observe MAA taken twice, undoubtedly don't select that example, that option. Do not choose. Another example for this, can we take nickel En taken twice plus 2? Can I take this example? Yes or no? In En, what are the donor atoms? Two similar, nitrogen. So it will present like this. See, nickel, nitrogen. It is not possible to classify nickel ethylene diamond bidentate ligand into cis and ars. So instead of remembering all these bulky means big structures, complex structures, remember the format. The reason I explained here. Okay. So remember the format. Which format? MAA taken twice. Do not shows. Cis-trans geometrical isomerism. Next, Roman number 6. Online students, are you getting Surabhi? Are you there, Surabhi, Aisha? Any doubts for you? You can ask Surabhi, Aisha. Adima? Are you getting Adima? Ubed. Next, Roman number 6. Bhakti, the problem there. MAB taken twice, plus or minus. This comes under shows cis-trans GA. See, within the square bracket, we mentioned one ligand, bidentate ligand. Within the square bracket, bidentate. See, some people will get confusion. This circle is a bidentate. Within the circle, bidentate ligand is present, and how many bidentate ligands are present? 2. Within that circle, AB is a bidentate. Once look at this, just one small verification. This circle, second circle also a bidentate, but what is the difference? See, AB means it is a bidentate with 2 different oxygen donor, here nitrogen donor. But in AA category, ethylene diamine, nitrogen is the donor atom, here also nitrogen is the donor atom. Got it now? Nitrogen donor. So within this square bracket AA means it is a bidentate with 2 similar donors. AB means bidentate with 2 different donors, nitrogen and oxygen. Got it? How many bidentate ligands are there? 2. Here how many bidentate ligands are there? 2. Now you realize that ligands list is very important, correct? For every concept we are using ligands concept classifications. Example, nickel GL taken twice. Nickel GL taken twice. Shows. Why? What are donor atoms in GL?
Oxygen.
Oxygen and nitrogen, 2 different. So AB category. Once look at this, all of you. Nickel. I am taking glycinato structure like this. O negative C double bond O. CH2. Oxygen and a nitrogen. And remaining part consider it as a curved line. You know already structure of GL. Nitrogen, oxygen. In this curved line, imagine the remaining part. Nitrogen, oxygen, curved line. You tell me, this is cis or trans? Cis or trans? This is Nitrogen. Similar atoms. Arranged by 90 degrees. Cis. Trans. Two similar atoms. 180. 180 degree. Trans. This is already open. What about DMG? DMG. What are donor atoms in DMG? Online students. What are donor atoms in DMG? DMG. Two nitrogens. Will it show? No. MAA type category. DMG means which do not show. Next, coordination number 6. Monodentate and bidentate. Monodentate, bidentate. Monodentate do not show category. Tell me
A6.
MA6,
MA5B.
MA5B category do not show. Example for MA6. What is MA6? COCl6. 6 chlorine atoms. COCl6 type do not show. Here M
A2B2C2 A
MA2 B2 C2 category.
MA3B3
MA3B3 category. Next
MA3B2C
MA3B2C category. MA3BCD category and so on.
XCD.
That is also important. MABCD category. MABCD, yeah, 6 are different. Bidentate do not show category. What is the
MA3
format?
MA3
MAA taken price do not show. Plus or minus and charge is common, but I am not writing. Do not show. Then you can write it shows. Shows here. Whenever you observe MA3B3 type, MA2B2C2 type, MA3B2C, do one thing. Remember this
the rest.
and the rest of the examples show. Do not show. Do not show. MAA taken price do not show. Here MAB taken price with two different donors. Bidentate with two different donor atoms. And MAA two bidentate ligands and two monodentate ligands. MAA taken twice.
B2
B2 or A2. You can take A2 also. AN is bidentate. This is monodentate. B2 is monodentate. Within the square bracket, bidentate ligands will be mentioned. Remember, within the brackets, bidentate ligands will be mentioned. Next category, AB taken twice.
C
B2 or C2, anything you can take. Next, This one, can I take this one? M, A, B taken twice. B, C. Yes. We can take like this.
MA taken twice, please.
M, A, B, C2 category. Any other category we can take. Okay? We remember this one. Remaining all cases. Examples. Did you copy? Online students. Within the square bracket, bidentate ligands will be mentioned. Brackets, not square bracket, brackets. See this square. Bidentate. Here also bidentate. Write the examples. So what is the simple trick? Remember the format which do not shows. This list is very easy, right? Remember which do not shows. Remaining shows. Do not shows all these. For example, if I give here this one M A4 B2. Is this form present here? No. So shows. What I am saying, remember this. If you get other forms, that will show. Right? M A4 BC. Yes. Because M A4 BC is not here. So it will show other forms, other formats. Got it? Right. First example. Roman number 1. MA6 category. Chromium H2O taken 6. Cl3. Will it show?
No.
Cl3 is there, no?
It does not matter. It is outside context.
Consider ligands and the format in the coordination sphere only. Within the coordination sphere, you tell me M. H2O is one ligand. 6 times it is present. MA6 category. It won't show. Roman number 2. M is A5. MA5. Example, cobalt. NH3 taken 5. Cl plus 2. Will it show? No. This is under which category? MA5B category. Do not show. Okay. Online students, are you writing? Online students. Are you following online students? MA2, B2, C2 category. One see. This is under which category? Shows or do not shows category? Shows category. What is the coordination number here? What is coordination number?
6.
What is coordination number?
6.
6. All are monodentate only. What I said, I mentioned bidentate in the brackets only. A is a monodentate, 2 times it is present. B is a monodentate 2 times. C is a monodentate 2 times. So 2 plus 2 plus 2 total 6. So coordination number is 6. Will it show? Yes. Example. With respect to any two halogens, we can arrange. With respect to two bromines, with respect to two chlorines, okay? A2, B2, C2 means it will shows. Right. How can we write cis form for this? Cis form. What is octahedral geometry? Octahedral structure. Octahedral structure. In the center, central metal atom is present here. Central metal atom. Okay? At four corners, four atoms. Like this. Four corners, four atoms. Above the square, this is square, right? Above the square, one atom. Below the square, one atom. Now you tell me. If I join this corner and this vertex, 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 how many faces I am getting? Four faces. 1, 2, 3, 4. Four faces above the square. And below?
Same 4.
This is one atom, this is another atom. If I place one atom, another atom, because six atoms we have right. If I join this corner and this vertex, here also I am getting so octahedral structure, octahedral geometry. Already we did that hybridizations. With coordination number 6, what is the hybridization? Octahedral. Hybridization sp3d2 or d2sp3 geometry is octahedral only. Already we completed, right? So with respect to any two, we can say. Can I consider like this BR? Two BRs are 90 degree. Remaining water molecules. But don't consider water molecules are in the transformer. Okay? With respect to halogens, we can classify this format. Some students will ask us here with respect to water molecules, this is trans. With respect to halogens, we can predict that this is or trans. Only A2, B2, C2 category, that is important. Okay? With respect to halogens, we are classifying here. Reality is halogens. With respect to halogens, we are classifying. Here two chlorines are cis or not? 90 degree. Here two chlorines are 90 degree. With respect to halogen atoms. Cis form. Transform means 180 degrees.
180.
Put bromine this side. Put chlorine this side. Two chlorines are opposite. Two bromines are opposite. Okay? Next, keep it in MA3B3 category. Will it show MA3B3 category? Because it present on the shows MA3B3, MA2B2 C2, MA3B3, MABCD, EF, all this. The geometrical isomerism exhibited by MA3B3 is called as facial. Facial and meridional. Facial and meridional, a type of geometrical isomerism. Direct question, neat level question. Which of the following shows facial and meridional? Which category? MA3B3 category. Online students, hello. Are you there? Hello. NEET level question is very easy. Identify the complex which shows facial and meridional. Very easy to identify. MA3B3 category. Examples are? What are the examples? Tell me examples. MA3B3. Give me any one example. Cobalt Cl3Br3. Can I consider? Cobalt NH3 taken thrice. H2O taken thrice plus 3. MA3B3 category. But facial means one thing. Take this example, COCl3Br3 example. Imagine cobalt is present in the middle, cobalt. Actually, explanation is not needed. Already we completed a NEET level question. Which of the following comes under facial, meridional, over. But once I'll tell you what is a facial, what is a meridional isomer. Cobalt is present in the middle. Okay. Cl. Br. You tell me two chlorines are arranged at the in the center. Cobalt is present. Cobalt. At this corner, chlorine. Okay, take this only as it is. Cobalt Cl. Br. Okay. Now, one atom present above the plane, right? In octahedral, the axial atoms are there now. These are equatorial axial. One Cl comes out. One Cl. At this vertex, Cl is present. Imagination is clear. Chlorine. At this chlorine. Now take this square. Turn like this. Now once look at this. Which atom is present here? Online students. One question. Online students. Which atom is present here? Tell me. Online students. Chlorine. This one? Chlorine only. Join all this. What you are getting? Triangle. You are getting? Triangle. Okay, same phase. 3 chlorine atoms, 3 similar atoms are present in the same phase or not? Same phase only, no? In this triangle, this is the triangle. Okay, means in this phase, chlorine. So facial. Okay. What are facial? Tell me. Online students, what is a facial isomer? Online students. Facial means Adiba, are you listening? Surabhi, Adiba, are you? 3 similar atoms. I forgot to place chlorine and bromine. Write chlorine, bromine here. After that definition. Ayesha, are you getting Ayesha? 3 similar atoms. Present in same plane. Same plane of a triangle. Look at this, meridonian. The plane which passes through the diagonal. This is chlorine atom. At this corner, one chlorine. Here also, one chlorine atom, right? So the plane which passes through the diagonal is called meridonian. So on that plane, three similar atoms are present. See the imagination. At one corner, one chlorine atom. Above one chlorine, below one chlorine, like this. Imagine another plane like this. Okay. Now pass the plane. One chlorine here, and another chlorine is on the corner, like this. We have to cut like this. This is meridonian. Okay, just some idea, not important for exams, right? How question will come? Which of the following exhibit facial and meridonial? MA3B3 category. That is enough. Okay. Right, next. MABCDEF category. Will it show? Yes. Next keep reading. Optical isomerism. What is condition for optical activity?
Presence of chirals.
Optical isomerism. According to organic chemistry, presence of chiral center or absence of symmetry element. So in complex compounds, we use second condition. Okay, complexes with absence of symmetry element. Complexes with absence of symmetry elements. Plane of symmetry. Symmetry element means plane of symmetry here. Symmetry element POS, plane of symmetry, are optically active, means they rotate plane polarized light towards left or right. Optically active compound means, once look at this, this is a chemical compound. When we pass the light through that chemical compound, after passing through that chemical compound, if this light rotates towards right or left, then this compound is said to be optically active. This is a chemical solution. You are passing one light through it. After passing through this compound, instead of passing in the straight line direction, if it rotates towards right or left, then this is said to be optically active. In organic, I taught. Okay, see one example. Trans. Just tell me. You just leave it at Atiba. Okay. We'll discuss later that. See, trans, COEN taken twice, Cl2. Once you tell me when this plane of symmetry is present or not. Transform. How to write transform? See, cobalt, Cl, N, ethylene diamine. You tell me this plane of symmetry is present or not? How? What is the plane of symmetry? It is an imaginary plane which divides the molecule into two equal halves. It is called as plane of symmetry. Like this, we can cut this. Cut this molecule into two equal halves. If we cut this, we are getting two similar halves. For example, watermelon. We can cut watermelon into two equal halves. The imaginary plane which divides the molecule or which cuts the molecule into two equal halves is called as Plane of symmetry. Plane of symmetry. You tell me transform is having plane of symmetry. So this is optically inactive. Inactive. Complexes with absence of symmetry element only active. But here symmetry element is present. What is the condition? Symmetry element should be absent. But here present. Plane of symmetry is present. Optically inactive. Optically inactive. Optically inactive. For transform, optical inactivity property is present. For cis form, optically active property is present. Cis form. I'll give the forms very easy. Very easy. Cobalt I took. Cobalt En taken twice. En. Cis form. Take cis form for this. COCl. Cl. Cis form. In this plane of symmetry is not present. POS is absent. So optically active. Optically active. So cis form is optically active. Transform is optically inactive due to presence of plane of symmetry, and this is due to absence of plane of symmetry. POS is absent, so optically active. We will get the three forms frequently. I'll give the three forms, which is optically active and which is optically inactive. Note down this. Examples category. First write optically active category. Cis M AA taken twice B2. Optically active category. Most frequently repeating examples list. M AA taken thrice category. Optically active. M AB taken thrice. See, very important. Once check M AA taken thrice will show geometrical isomerism. Will it show geometrical isomerism? Will it show GI, geometrical isomerism? See the notes. It won't show geometrical isomerism, but it will show optical isomerism. Given MEAA taken thrice under, do not show category. That is the important point. It won't show GI, but it shows optical isomerism. Geometrical isomerism is not exhibited by MEAA taken thrice, but optical isomerism is possible. MEAB taken thrice also possible. And MABCD EF MABCD tetrahedral complexes. TD tetrahedral MABCD EF MABCD tetrahedral complexes. So most frequently coming examples is show optical activity. Do not shows category. MA4B2 MA4BC category. MAA taken twice category. Do not show. Plane of symmetries are present. Even MA3B3 also. Note down this also. MA3B3 category. Add one another important one. MA3B3. Ma3B3 also. Ma3B3. Mostly 99% cases, 99.99% cases, these examples only will come in the optical isomerism questions. Okay. Now very important, calculation of number of isomers. Keep heading. Calculation of number of isomers. 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 How many isomers are possible? How many isomers are possible? For CONH3 taken twice, En taken twice. How many isomers are possible for CONH3 taken twice, En taken twice? Plus 3. A very important model question. This is in the form of, what is its format? Tell me. A2 En taken twice. Correct only? Sorry. A or B2. Okay, you can consider B2 also. Correct only, no? Format is right. You once check. How many? 3 isomers are possible. What are the 3 isomers? Two optical isomers and one geometrical isomerism is possible. Let us see. Okay, first I give an important example only. Take that example. See all of you. First I am writing transform. Trans. H2 over NH3 again. Sorry, NH3. This is one ethylene diamine. This is one ethylene diamine. This is transform. Trans. Correct only, no? CO in 2 times. NH3 2 times. Plane of symmetry is possible here. Optically active or inactive? This is inactive form. But if this is a trans, only one trans. For cis. See, this is cis. We know for cis, optical isomerism is possible or not?
Yes.
N. Cis is optically active. If optical activity is present, mirror images are possible. Whenever one compound is optically active, we have to take its mirror image also. We have to consider this as a 1+1 enantiomeric relationship. Clear? This is optically active means internally you have to imagine 2 compounds here. This is not optically active. This is one compound only. In organic already we did this. Its mirror image also present. Na? Another enantiomer is present. So 1+1. So total how many? 1, 2, 3. 2 optical isomers. Okay, 1 geometrical isomer. Organic chemistry. Now I'll give you few formats and their number of structural isomers. Okay, this is one important model question. That's why I given first. Ayesha and Surabhi Obed are getting optically active. Optically active means, remember, whenever you get one compound is optically active, you have to imagine 1+1. For optically active compounds, mirror images are possible. For example, if I stand in front of mirror, 2 persons will appear or not? Original and image. For optical active compound, nothing but a person standing in front of the mirror. Optically active compound means a person standing in front of the mirror. Original person and image. So two. Note down some important of formulas and their possible structural isomers. Right? Keep heading. Number of structural, not optical. I am writing structural only. Number of structural isomers. Number of structural isomers. Ma2B2 type. Ma2B2 type. Two geometrical isomers. Or two structural isomers. 2GI. 2GI. GI nothing but it is not structural. Sorry. Two geometrical. 2GI. I should not call it as a structural because it goes to ionization, that category. Two geometrical isomers are possible. What are the two geometrical isomers? One is cis and one is trans. Ma2B2 category. Ma2PC category also. Note down how many? Two GS. Two geometrical isomers. Very important. MABCD. Three geometrical isomers. If you remember these formats, NEET level mostly question will come from this only. Okay. Ma3, MABCD, 3 GS, 3 geometrical isomers. Ma3B3. Can you guess Ma3B3? Just now I given Ma3B3 special type. What is that special type? Facial and meridional. So how many? Facial meridional. Like cis trans, facial meridional means how many? Two only. Cis trans. Similarly, facial meridional. Two. Actually, we have one method. What is that method procedure? We have to interchange the ligands. Okay, this is shortcut. Remember, I'll explain how to do original method. That is a time taking hit and trial method. You have to interchange the ligands. You have to check. Instead of that, remember this. Okay, format. It will take some time, but once if you learn, this is only the easy method. Instead of cross checking. Okay. Now look at this, all of you. Ma3B3 means 2GI. Now do one thing. Ma3, write B3 like this. B2C. B2C. Here how many? Increase one. Okay. 2GI. Next what I am doing. Ma3. BCD completely change. BCD. Here how many you wrote? Okay, some important forms. And tomorrow I'll explain the original method. If you get any complex, we can do it. But for NEET level, mostly within these forms only questions will come. Next, M, A, B, C, D, E, F. 15. M, A, B, C, D, F, 15. M, A, B, C, D? M, A, B, C, D. M, A, B, C, D. 3. M, A, B, C, D, E, F. 15 times. We can consider, but geometrical I given. Geometrical. Only for geometrical. Okay. 15 GAs are possible. Yesterday I given one formula. When ambidentate ligands are present, how to find the number of isomers. Okay, keep heading. Yesterday also given a very important number, not write directly. When ambidentate ligands are present, tell me, number of GS are 3. 3 into 2 to the power. How many ambidentate ligands are present? You tell me in this how many are ambidentate? NO2 is ambidentate ligand. SCN is ambidentate ligand. NO3 is not ambidentate. Cl is not ambidentate. So 2 to the power 2. So 3 into that is equal to. Okay, once correct that. Online students, please correct that. Did you correct? Not plus, that is into. Okay, by mistake I given. Simple questions will do. Okay, but this is question didn't come in the NEET. Okay.